This video uses the primary ratios, trig ratios, to solve problems. So here's a problem. A sailboat's approaching a cliff. The angle of elevation from the sailboat to the top of the cliff is 35 degrees. The height of the cliff is known to be about 2,000 meters. And the question is, how far is the sailboat away from the base of the cliff? Best way to start these problems is with a picture. So I'm going to start with my cliff. It's about 2,000 meters. We know that there's a boat. We're trying to figure out how far away it is from the base of the cliff. So this is the unknown value. And we're given some information about an angle of elevation. So we should talk a little bit about some terminology. The angle of elevation is always measured from the horizon looking up. So from the horizon looking up, this right here would be the angle of elevation. There is another angle that we sometimes hear about in these problems or read about in these problems. It's called the angle of depression, and that's measured from the horizon looking down. So from the horizon looking down is called the angle of depression. Really important that you get these angles right, otherwise you'll have the wrong angle in the wrong spot. And again, this is the horizon here, so always measured from the horizon. So given that information, we should be able to complete our diagram. Here's the horizon. We want the angle looking up from the horizon, so this angle in here has to be the 35 degrees in the question. Now we have our triangle. We're going to assume that the water and the cliff meet at 90 degrees, so this is a primary trig problem. We're going to label the side lengths. Here's the 90-degree angle over here. The opposite end is the hypotenuse. The angle that we have is here. The opposite end is going to be the opposite side. And finally, the last side is the adjacent side. At this point, we're going to look at the information that we have. So we have the opposite, and we're trying to find the adjacent. The trig ratio that uses opposite and adjacent is tan. So the tan of theta is equal to the opposite side divided by the adjacent side. And from here we can plug in the values that we have. We know that the angle is 35 degrees, the opposite side is 2,000 meters, and the adjacent side is unknown. So the variable that we're trying to solve for is in the denominator here, x. Easy way to deal with that is just to flip this fraction upside down and look at the reciprocal. So the reciprocal is this right here, and we get that just by swapping the numerator and denominator. Now if we look at the reciprocal of the fraction on the right, we have to do the same thing with the fraction on the left. Remember that tan 35, any number, can be written as itself over 1. So tan 35 is the same as tan 35 over 1. Because we looked at the reciprocal on the right, we need to do the same thing here. So the reciprocal of tan 35 is 1 over tan 35. And now we have an equation that we can solve. We're trying to solve for x, so get this x on one side of the equation all by itself. Tan 35 is a number. We can go to our calculators and get that value. And if you plug tan 35 into your calculator, you should get 0.7002. And again, make sure that your calculator is in degree mode. You should have a little D or a DEG in the top, otherwise you'll get the wrong answer. We want to solve this equation, so to solve this equation, we're trying to solve for x. You could, if you wanted to, figure out what 1 divided by. You could evaluate 1 divided by 0.7002. I'm going to try to sort of streamline this a little bit. We're trying to solve for x. X is being divided by 2,000 right here. We want to undo that division by 2,000, so we need the inverse operation. The inverse of dividing by 2,000 is multiplying by 2,000. And if we multiply by 2,000 on the right, we need to multiply by 2,000 on the left. So we can go to our calculators. Well, 2,000 divided by 2,000 is 1. You don't need a calculator for that. So we're left with x on the right. And now we can go to our calculators and do 2,000 times 1 divided by 0.7002. And we should get 2,856.3. So that means that the distance of the sailboat to the cliff is 2,856.3 meters. We were asked a question. We should answer that question. So a little statement. Therefore, the boat is about 2,856 meters from the cliff. So, in summary, when you're given these problems, the best way to start is to start with a picture, plug in all the values, and then from there you can actually go through, do your calculations, and then make sure you answer the question at the end.